When you import the Lowpoly recipes asset, you'll be prompted with the launcher window here. This can be disabled by clicking down here. If you have disabled it, you can always get it back via the menu. So the launcher window provides access to all of the recipes found within the current project. It also has buttons that will take you off to the online wiki if you find a bug, you've got a question you want to ask, or there's a feature you'd like adding. Obviously, any of these, let us know the build version number. We'll open up first demo. So each recipe has a title, a description, and then a set of prerequisites. These are things that must be met before you can build the recipe. Now, in this case, all the prerequisites have been met. Hence why we've got build. If they weren't, you'd get a big red cross here. And hopefully we'll see that later on. These buttons here, we can locate the recipe within project folder. If we click open, and if we just move this out the way, so we now have the node viewer for the recipe. This window can either be opened via the launcher, or if we close that, we can simply double click on the recipe and it will launch. Center mouse button, hold and pan, zoom in and out with the scroll wheel, and if we hit home, it will recenter. Okay, so each of the nodes here corresponds to a recipe or an instruction that forms part of our recipe. We can click items on the view, and it corresponds to the item in the selection in the project view, and obviously the inspector. We can also use the arrow keys, up, down, left, right. For this demo, if we scroll down and we build the recipe, now the purpose of this recipe was to separate the mesh into, or the meshes of these trees, or two trees and a stump, into submeshes that correspond to the UV features that the mesh is using. Looking back at the recipe, so the recipe has a set of requirements. These are things that must be met before the recipe is run. Then a series of instructions. Now, in this case, these instructions here are creating materials, basically some solid color materials. We then have an instruction that will process a set of prefabs. And for each of these prefabs, it will run these instructions. Now, these instructions are, the first one is to process meshes. This will process any of the meshes found within these prefabs. For each mesh that is found, we're going to run texture feature extractor. So what that will do is that will look at this file here, which is a texture feature set. This defines a set of regions that could be used by the feature extractor to separate out the mesh into submeshes. What we then have is a remove data channels. So as we're going to use solid colors with submeshes, we no longer need the UV channel. So this node basically allows us to purge the resultant mesh of any of this data. Following on from that, as this is a demo, we want them all in a nice straight line. That's the purpose of this instruction. And then finally, we have save prefab. And this will basically just then save a copy of the prefab and our modifications to a location in our assets folder. That location is defined within the recipe. So in this case, it's output demo 1. And then it uses subfolders for the meshes, prefabs, materials, and textures. So we can have a quick look at that now. There we go. So we have our new prefabs, our modified meshes. In fact, if we look at those, we should see there are actually 2 submeshes in there. Same with those. Okay, and materials, we have some new materials. Right. Okay, so let's close that down. Let's have a look at demo 2. So demo 2 is very much, it produces the same output as the first demo, except it goes about it in a different way. Whereas the first demo used predefined regions within the texture, the second one uses a spatial extractor. So in this case, so what it's doing is it's looking for faces whose UV is within a certain threshold of each other. And so with that, we can actually separate out the mesh into those regions. Now this extractor will produce submeshes labeled basically 001, 002, etc. So we need to rename those, and in some cases merge 2 separate submeshes together, where they may be in the same kind of region, however they're not. They're too far spatially separated. So if we look at this first one, so these are basically merges, and they are very specific to a particular mesh. So we have a filter here that just tells it which mesh to work on. For the first tree, it'll have separated them quite nicely, and all we're really doing is renaming the submeshes into meshes that match the materials. And in doing that, the mesh processor will be able to associate the submesh with that material. Okay, so that's on the T2, very similar. Now the stump here, the kind of the inside part of the wood, or the core wood, actually gets split into 2. So in terms of matching, we've got a number of ways we can put matches in here. We can just put it in straight, such as that, or we can define an array, or we can use wildcards either at the beginning or the end, or both, or we can use regular expressions. And regular expressions are triggered by putting a hash at the beginning and then implementing a standard regular expression. Okay. Again, we remove the channel and we save the prefab. So if we just build that, and it's produced another row, which should be very similar. Okay. Demo 3. Okay, so Demo 3 is a little bit different. So what this one is aiming to do is, instead of creating submeshes, it wants to separate the mesh. And in this case, it's a skinned mesh. It's a basically a character that what we want to do is separate out the arms, the head, and the body. So that, for instance, we could use it as a within an FPS type game. So how do we go about that? Well, it's very similar to the start to the others. We just have a single character or single prefab, which is our character. The main difference comes firstly in the process meshes, where we now have extract mesh. So we could have basically used by default it uses submesh, but we can change it here to extract mesh. So that will then create separate meshes with separate game objects in the prefab. Okay, so the first extractor is going to extract the arms, and what this is doing is you provide basically a set of thresholds for the different bones. So these are basically, we'll look at the bone weights and determine whether a particular face is going to be within, it'll be extracted within this mesh. Okay, so we can, if you got the weightage here, we can also select how we want to match, basically whether all the vertices of the face must meet these requirements. Most, i.e. 2 out of 3, or any, so if any one of them matches. But we'll leave that for all there. So we have those for the arms. We have one for the head here. This is a very simple model, as you will see in a moment. And then we have what remains. So this basically will take anything that wasn't matched by these two extractors, and then we'll basically put it into its own submesh, which we name as body. Okay, so if we run this, build. Okay, and here's my little character. Okay, so we can see here each of these different parts here has been separated out into a separate mesh. And well, the hat is a completely separate up there, but yes. Okay. Right, let's have a look at the fourth demo. Okay, so the fourth demo is what we're attempting to do here is remap the UVs from one layout to another. Okay, so but the actual outputs of our targets we're actually going to create at the same time. So this create texture allows us to define features that we want in our new texture. And these can actually be, you can put these in manually, or you can actually create a definition file and load them up. When we build the texture, it will create a feature set that describes the layout, and that is then used by this UV remapper. And the UV remapper allows us to provide a mapping from one feature set to another. In this case, it's relatively simple because I have the names are the same. And if the names are the same, then the this auto-populate will create these mappings for you. Obviously, if your names are all different, then you will have to go through and create that mapping. And again, you can load these from file, and there's I think some example files. Okay, so if we build that. Okay, and so we have the same, but it's using a different material. But if we now this is where I really should have launched the. No, this is where I should have shown you the originals. So let's just load up the original tree here. Let's bring that up forward. Okay. So the original tree here uses a this swatch. This uses just a fairly simple swatch. But our remapped one uses a different layout and with a lot of empty space. So how do you go about creating a recipe? So if we create a folder and we add a recipe in. Now we can either go through and use the create menu, and we've got access to all of our instructions within here, or we can select the recipe type down here. So this is because I'm just going to put login, and if we then go add, it creates our new instruction, and the instructions down here. Now in this case, it's very simple. It's just a simple hello world. And if we run that, we get hello world. But obviously we want something a little more than that. So what we can do, so instructions, process prefabs, yes, that'll be interesting. And we go to our assets, and in this case we're going to put let's put a sword in. Okay, so we can drop our prefab in there, but we could obviously just hit done plus there, and but we'll put the sword in there, and if we build that, go to our scene, and we have a sword. Right. Okay. That hopefully should get you started. On the wiki, there are plenty more examples, particularly using some of the kits by the likes of Cinti. Over time, these should increase. You should get more of them on. Okay, enjoy.